Hello dear students, in this video we'll have a recap of the topics, namely perpetuity, sinking fund and valuation of bond from financial mathematics. Now this unit financial mathematics, it has a weightage of 15 marks. The first topic we will see perpetuity. First we will see what is perpetuity. A perpetuity is an annuity where payments continue forever. So it is a perpetuity in which the annuity will continue for infinite period of time. Under this present value of perpetuity, we have to remember two different formulae. The first one is present value of the perpetuity where rupees R is payable at the end of each period, and next is present value of perpetuity where rupees R is payable at the beginning of each period. So the first formula is present value of perpetuity of rupees R payable at the end of each period. The first one being due one period hence, it is given by P is equal to R by I, where R is the size of each payment and I is the rate per period. And next we have present value of perpetuity of rupees R payable at the beginning of each period, the first payment due on the present value. So this annuity, it can be considered as an initial payment of rupees R which is followed by a perpetuity of the above type. So on the first day a payment of rupees R is being made, and then it is similar to this present value of perpetuity of rupees R payable at the end of each period. So it is R plus R upon I. So here P is equal to R plus R by I, where rupees R is payable at the beginning of each period. Again R is the size of each payment and I is the rate per period. Now we will see some problems based on this present value of perpetuity. First question, find the present value of a sequence of payments of rupees 1000 made at the end of every 6 months and continuing forever if money is worth 10% per annum compounded semi-annually. Similar question was asked in the sample paper for 2 marks. So here we need to find the present value of a sequence of payments of rupees 2000 which is made at the end of every 6 months and it is continuing forever. So it means we have to find the present value of perpetuity of this rupees 2000 which is made at the end of every 6 months, and we have interest rate as 10% per annum which is compounded semi-annually. So first let us write what is given. R is equal to rupees 2000 and the rate per period I is, it is 10 by 100 into half. So it is 0.1 by 2 or it is 0.05. Here since money is worth 10% per annum which is compounded semi-annually, so the rate for every 6 months it is given by, it is 10% divided by 2 or it is 0.1 by 2 which is 0.05. We have the present value of perpetuity. Now here we can see that the payments are made at the end of every 6 months. So the present value of perpetuity P is equal to R upon I. R is 2000 and I is 0.05. So this is equal to rupees 40,000. Therefore P is equal to rupees 40,000. Writing what is given and finding I, it carries 1 mark, and then writing the formula for present value of perpetuity, substituting the values, and the final answer carries 1 mark. Moving on to the next question. Assume that Reena holds a perpetual bond that generates an annual payment of rupees 700 each year. She believes that the borrower is creditworthy and that an 6% interest rate will be suitable for this bond. Find the present value of the bond. So here it is given Reena holds a perpetual bond. So here the investment is a perpetual investment which generates an annual payment of rupees 700 each year, and it is given the rate of interest is 6%. we need to find the present value of the bond. So it is present value of perpetuity of this bond. So first let us write what is given. R is equal to rupees 700, and here the interest is, here the payment is made annually, so the rate per period it is 6% or it is 0.06. We have the present value of perpetuity given by R upon I, or it is 700 upon 0.06, or it is 70,000 by 6, which is 11,666.67. Therefore, P is equal to 11,666.67 rupees. Next question. A sum of rupees 75,000 invested at R% compounded quarterly will provide payments of rupees 800 each at the end of 3 months. Find the value of R. So here it is given a sum of 75,000 invested at R%, which is compounded quarterly. It will provide payments of rupees 800 each at the end of 3 months. We need to find the value of R. So here the present value of the investment is given and the periodic payment R is given. We need to find the rate of interest. Given P is equal to rupees 75,000, R is equal to rupees 800. And the rate per period, it is, here the payments are made at the end of 3 months. So the rate per period will be R by 4. So now we can calculate R using the formula present value of perpetuity. We have P equal to R by I. So this implies 75,000 is equal to 800 upon R by 4. So we have 750 is equal to 32 by R, or R is equal to 32 upon 750. It is equal to 0.0427. So R is 0.0427 or it is 4.27%. Therefore, R is equal to 4.27%. Next question. What sum of money is needed to invest now so as to get rupees 8,000 at the beginning of every month forever if the money is worth R% compounded monthly? So here they have said we need to find the sum of money that we need to invest now. That is, we need to find the present value of perpetuity so that we can get a periodic payment of rupees 8,000 at the beginning of every month. So we have to find present value of perpetuity when the payments are at the beginning of every month. And money is worth 6% per annum compounded monthly. So first let us write what is given. Given R is equal to rupees 8,000 and the rate per period I is equal to 6% by 12, or it is 0.06 by 12, which is 0.005. We have P is equal to R plus R by I. Since here we need to get rupees 8,000 at the beginning of every month forever. So we need to find present value of perpetuity when the payments are made at the beginning of each period. So it is 8,000 plus 8,000 upon 0.005. So it is 8,000 plus 16 lakhs, which is 16 lakh 8,000. So the sum of money that has to be invested now is 16 lakh 8,000. Therefore, a sum of rupees 16 lakh 8,000 need to be invested. Next question. The present value of a perpetual income of rupees X at the end of each 6 months is rupees 40,000. Find the value of X if money is worth 6% compounded semi-annually. So here the present value is given. We need to find the payments which are made at the end of each 6 months. Given P is equal to rupees 40,000. I is equal to 6% which is compounded semi-annually. So for 1 year it is 6%, for 6 months it is divided by 2. So 6% by 2 is 0.06 by 2, it is 0.03. And now we have to find the size of each payment. That is, we have to find the amount of income. R is equal to rupees X. We have P is equal to R by I. Here the income is received at the end of 6 months. So we have P as R upon I. P is given as 40,000, R is X and I is 0.03. So from this we get X as 40,000 into 0.03, which is 1200. Therefore, X is equal to rupees 1200. So this rupees 40,000 is the present value of this perpetual income rupees 1200 when money is worth 6% compounded semi-annually. Now we have sinking fund. A sinking fund, it is a fund which is established by a company or a business entity by setting aside revenue over a period of time to fund a future capital expense or repayment of a long-term debt. So it is a fund which is basically established by a company or a business entity where the fund will be used to meet a future capital expense or for repayment of long debt. The capital expense can be in the form of purchase of machinery or replacement of an old machine, etc. And now it is a fund which is accumulated for the purpose of paying off a financial obligation at some future designated date. And now we have the difference between sinking fund and savings account. Here in both these, we have to set aside some amount of money for the future, but the main difference is the sinking fund, it is set up for some particular purpose, whereas a savings account, the money which is available in savings account, it can be used for any purpose. That is the difference between sinking fund and savings account. Now we have the formula. The periodic payments of rupees are made at the end of each period required to accumulate a sum of rupees A over n periods with interest charged at the rate I per period. It is given by R is equal to A upon S at an angle n for I rate per period. So this n at an angle n for I rate per period is nothing but it is the future value annuity factor, where S at an angle n for I rate per period is 1 plus I the whole raised to n minus 1 upon I. So from this we can find the accumulated sum as R into S at an angle n for I rate per period, or it is R into 1 plus I the whole raised to n minus 1 upon I. So this is how we can find the lump sum amount that has to be accumulated when the size of each installment or payment is given by R, the rate per period is given by I, and the number of installments is given by n. Now here this is the formula which is used when the periodic payments of rupees R is made at the end of each period. On the other hand, if the periodic payments of rupees R are made at the beginning of each period, then this R, the relation between this R and the amount to be accumulated in the sinking fund A over n periods with interest charged at rate I per period, it is given by A is equal to R into S at an angle n plus 1 for I rate per period minus 1. We already saw S at an angle n for I rate per period. The future value annuity factor is 1 plus I the whole raised to n minus 1 upon I. Here S at an angle n plus 1 for I rate per period will be 1 plus I the whole raised to n plus 1 minus 1 upon I. So this implies A is equal to R into 1 plus I the whole raised to n plus 1 minus 1 upon I minus 1. There is 1 minus 1 outside here. So we have to remember that. This is the formula when the periodic payments are made at the beginning of each period. So here again R is the size of each installment or payment, I is the rate per period, N is the number of installments and A is the lump sum amount to be accumulated. A question on sinking fund was asked for 4 marks in the sample paper. Now we will see a similar question here. A machine costs a company rupees 52,000 and its effective life is estimated to be 25 years. A sinking fund is created for replacing the machine by a new model at the end of its lifetime when its scrap value realizes a sum of rupees 2,500 only. The price of the new model is estimated to be 25% more than the price of the present one. Find what amount should be set aside at the end of each year out of the profit for the sinking fund if it accumulates at 3.5% compounded annually. So here the cost of the machine is given, its effective life is given, and we have to have a sinking fund for replacing this machine at the end of its lifetime where the scrap value is only rupees 2,500. And it is also given the price of the new model is 25% more than the price of the given model. We need to find what amount we have to set aside at the end of each year out of profit so that the sinking fund accumulates 3.5% compounded annually, and they are given 1.035 the whole raised to 25 is 2.3632. Now let us write the formula first. The amount of sinking fund A, it is given by A is equal to R into 1 plus I the whole raised to n minus 1 upon I, where R is the periodic payment, I is the interest per period and n is the number of periods. Here the amount is set aside at the end of each year. So we are using this formula. Now let us find the cost of new machine. Here it is given the price of the new model is estimated to be 25% more than the price of the present one. So the cost of the new machine will be the cost of the present machine, which is 52,000 plus 25% of 52,000. So it is 52,000 by 4, which is 13,000. So this is equal to rupees 65,000. Now the cost of the new machine is rupees 65,000. The amount that has to be accumulated in the sinking fund is cost of the machine minus the salvage value. The salvage value or the scrap value is given as 2,500. So it is 65,000 minus 2,500, which is 62,500. So this is A. And then the rate per period is given. I is Here the amount should be set aside at the end of each year, and the interest rate, annual interest rate is also 3.5%. So I is 3.5%, which is 0.035. And then N is the number of periods, it is 25. We have 62,500 is equal to R into 1 plus 0.035 the whole raised to 25 minus 1 upon 0.035. So this implies 62,500 into 0.035. It is equal to R into. Here in the question itself they have given 1.035 raised to 25 is 2.3632. 2.3632 minus 1. Now this, when we multiply 62,500 into 0.035, we get 2,187.5. This is equal to R into 1.3632. So from this we have R as 2,187.5 upon 1.3632. This is equal to 1,604.68. Therefore, amount to be set aside R is equal to rupees 1,604.68. So writing the formula, it carries 1 mark. Then finding the amount to be accumulated in the sinking fund and writing what is given and substituting all the values in the formula carries 1.5 marks. And then the remaining steps and finding the final answer, it carries 1.5 marks. So a total of 4 marks. Moving on to the next question. A firm anticipates a capital expenditure of rupees 80,000 for a new equipment in 5 years. How much should be deposited quarterly in sinking fund? Carrying 12% per annum, compounded quarterly to provide for the purchase. So here it is given, a firm is anticipating a capital expenditure of rupees 80,000 for a new equipment. We need to find the amount that should be deposited quarterly in the sinking fund, which is carrying an interest rate of 12% per annum, compounded quarterly. Given 1.03 the whole raised to 20, it is equal to 1.8061. Now let us take, let R be the quarterly deposit. Then the amount of sinking fund A is given by A is equal to R into 1 plus I the whole raised to N minus 1 upon I. Or from this we can write R as A into I upon 1 plus I the whole raised to N minus 1. Where R is the size of each installment or payment, I is the rate per period, N is the number of installments, and A is the lump sum amount to be accumulated. Then the question it is given, A is rupees 80,000 because the firm anticipates this expenditure for new equipment in 5 years. So we have A as rupees 80,000. Then the rate per period I is, here we need to find the amount to be deposited quarterly. So I will be 12% upon 4. So it is 12% by 4, or it is 0.12 by 4, which is 0.03. and then the number of installments. N is equal to 5 into 4, which is 20. Because quarterly deposits are made, so for 1 year 4 deposits will be made, 5 years 5 into 4. We have R is equal to A is 80,000 into I is 0.03 upon 1 plus 0.03 the whole raised to 20 minus 1. So this is 80,000 into 0.03, 2,400 upon 1.03 the whole raised to 20 minus 1. 1.03 the whole raised to 20 is 1.8061 minus 1. So it is 2,400 upon 0.8061, or it is equal to 2,977.29. Therefore, quarterly deposit equal to rupees 2,977.29. So this is the quarterly deposit. Now moving on to the next question. If Mr. Nirav deposits rupees 250 at the beginning of each month in an account that pays an interest of 6% per annum compounded monthly, how many months will be required for the deposit to amount to at least rupees 6,390? So in the previous two questions, A, I and N were given. We need to find R. In this question, that is which is of the second type, A, R and I are given. We need to find N. Given log of 1.1328 and log of 1.005, the values are given here. So here it is given, Mr. Nirav deposits rupees 250 at the beginning of each month in an account which pays an interest of 6% per annum and it is compounded monthly. So R is given as 250 and the interest rate per annum is 6%. So I will be 6% by 12 since it is compounded monthly. We need to find the number of months that will be required for the deposit to become rupees 6,390. So A is rupees 6,390. This is A, this is R, and we need to find the rate per period using 6% upon 12. Now we need to find N, that is the number of months that will be required for this to become 6,390. The amount of sinking fund A, when the payments are made at the beginning of each period, it is given by A is equal to R into 1 plus I the whole raised to N plus 1 minus 1 upon I minus 1. So here this is the formula when the payments are made at the beginning of each period, where R is the periodic payment, I is the interest per period and N is the number of periods. Given A equal to rupees 6,390, R is equal to rupees 250, the rate per period I is equal to 6% by 12. So it is 0.06 by 12, which is 0.005. Now we need to find N. We have 6,390 is equal to 250 into 1.00, 1 plus 0.005. I am substituting each of these values in this formula. the whole raised to n plus 1 minus 1 upon 0.005 minus 1. So this implies 6390 upon 250 equal to 1.005 the whole raised to n plus 1 minus 1 upon 0.005 minus 1. Now this when we divide, we get it as 25.56 equal to 1.005 the whole raised to n plus 1 minus 1 upon 0.005 minus 1. Let us bring this minus 1 to the other side, it becomes plus 1. So we get 26.56. Here we have 0.005, bring it to the other side into 0.005 equal to 1.005 the whole raised to n plus 1 minus 1. So this when we simplify, we get it as 0.1328 equal to 1.005 the whole raised to n plus 1 minus 1. Or we get 1.1328 equal to 1.005 the whole raised to n plus 1. Now if we take log on both sides, we get log 1.1328 equal to n plus 1 log 1.005. So from this we get n plus 1 is equal to log 1.1328 upon log 1.005. So the values of these are given in the question. Let us substitute here. So from this we get n plus 1 is equal to log 1.1328 is 0.05415 upon log 1.005 is 0.00217. This we get it when we divide, we get it as approximately 25. So n plus 1 is 25. It means n is 24 months. Therefore n is equal to 24 months. So this is the second type when A, R and I are given and we have to find n. Now moving on to the next type. Mr. X plans to save amount for higher studies of his son required after 10 years. He expects the cost of these studies to be rupees 1 lakh. How much should he save at the beginning of each year to accumulate this amount at the end of 10 years if the interest rate is 12% compounded annually? So here it is given X plans to save amount for higher studies for son which is required after 10 years and he thinks that the cost is rupees 1 lakh. We have to find the amount that should be saved at the beginning of each year to accumulate this amount at the end of 10 years if the interest rate is 12% compounded annually. So here let us take, let R be the annual deposit, then the periodic payments of rupees R which is paid at the beginning of each period. It is given by the relation A is equal to R into S at an angle n plus 1 for I rate per period minus 1. Or A is equal to R into 1 plus I the whole raised to n plus 1 minus 1 upon I minus 1. This is the formula when the periodic payments are made at the beginning of each period. So given the amount that should be saved is rupees 1 lakh. So A is rupees 1 lakh and then I is 12% and it is compounded annually. So I is 0.12 and then the number of periods. N is it is required after 10 years. So N is 10. So we have 1 lakh is equal to R into 1 plus 0.12 the whole raised to n plus 1. In the formula we have n plus 1, so 10 plus 1 is 11 minus 1 upon 0.12 minus 1. So this implies 1 lakh is equal to R into 1.12 the whole raised to 11 minus 1 upon 0.12 minus 1. 1.12 the whole raised to 11 is given as 3.4785. 3.4785 minus 1 upon 0.12 minus 1. Or it is 2.4785 upon 0.12 minus 1. Now this 2.4785 upon 0.12, it is 20.6546 minus 1. So from this we have R as 1 lakh upon this 20.6546 minus 1 is 19.6546. So this when we simplify, we get it as rupees 5087.87. Therefore, R is equal to rupees 5087.87. So here we have A, I and N given. We need to find R, and the payments are made at the beginning of each period. So we have to use this formula.